Lexing here. I am at the NU. I lead the computational media lab. So here's a bit of a background of the three main topic areas my lab works on. I'm going to give you a teaser of each area. This talk will be structured around hopefully 4 different demos. If I'm running short in time, it might become 3. So I'll directly dive into the first area, which is an excuse for me and my team to spend a lot of our time to work, to watch YouTube and understand why videos get popular, both the pop songs of the last decade on the left, and also the pop songs of 300 years ago that still continues to gather attention. And as we know, human attention is a scarce resource nowadays, and it affects our productivity, voting outcomes, and many other like important questions in life. So one observation or insight I would like to share from our 5 years of data gathering analysis and mathematical modeling is that popularity, as in, for example, daily number of views of a YouTube video, is inherently unpredictable. It is the result of what we call endogenous response, like word of mouth diffusion through networks, interacting with exogenous promotions, the real world events, or discussions on Twitter being talked about on TV shows and so on. This is also the only slide with an actual mathematical equation. So our model illustrated in the plot below is that we can think of a online social platform as a combination of network effect, system memory, basically how soon a video is forgotten, and content quality being essentially like acted upon using, let's say, Twitter shares as input and then the view counts as output. This is described by the equation above, which is the stochastic expectation of what's called a Hawk's self-exciting point process. Let's not spend time digesting that equation right now. What we can do is to simplify the insights from this equation into 2 dimensions. The y-axis is sensitivity to external promotion S of t. That's the multiplier parameter mu. And then the x-axis is what we call like a virality index or area under the impulsive response of this linear system. We have also shown that the fundamental model self-exciting processes have inherent connections to stochastic epidemic models and can be universally represented using state-of-the-art learning tools. So I'm going to use this 2-dimensional representation to show you how it affects our reasoning analysis about each videos. We nickname this as the Indo-Exo map, right? As shown on the upper left-hand side. So each dot here is a video. So if I just move my zoom things around, so here's the live version of the video. We're now looking at the video corresponding to this big red white dot here. It's one of the videos summarizing ice bucket challenge videos. For some of you might still remember about 6-7 years ago, this was a thing on the internet. So in contrast, then appropriate for this audience, there's this red dot down under, which is it's not very sensible to external promotions, but it's slightly more viral. And this is a video on how many kinds of infinities are there. So this kind of mathematical topic are intrinsically interesting, but you can see that even if people promote it on the internet, the audience might be a bit small, right? So this is our first demo, and after this work, we realized that each piece of online content is not isolated. For example, on YouTube, music videos or all the videos form a big network based on the recommender system, what the recommender system want people to see. Basically, there's a directly link between the video that you're watching to the videos that's being recommended to you on the right-hand side. So Siqi Wu, my PhD student, performed the first measurement study, and here's an example. The release of a popular song, Hello by Adele, essentially caused or triggered an attention spike across many different songs, some of which, for example, Skyfall, they are not directly recommended to Hello, but the spike goes through other songs such as Rolling in the Deep, right? So we proposed one forecasting method called ARNet, which is essentially network-specific regression models. Our next effort in representing and forecasting networks of time series is best illustrated by this example, which are Wikipedia traffic. So the center node is Yellow Vest movement, a political movement, in recent one in France. And the traffic to this is driven by a number of other pages that hyperlink to it, right? And the link strength is estimated by a neural network model that has a recurrent structure layer decomposition with forecasting backcast components with state-of-the-art performance. So the data set underlying this is the web traffic for more than 300,000 Wikipedia pages. This 3 orders of magnitude larger than existing network of time series models. So this leads us to the next demo, which is called attention flow. You can play with it on the web. So shown here is a screenshot showing the effects of music videos driving traffic to each other. I'm going to show, okay. If I go to the live version, this shows the traffic time series on top for Wikipedia page. This is a character on Star Wars, right? And then you can, if I mouse over, it shows you that some of these attention spikes are synchronized with the release of Star Wars episodes and with the actor who plays this character. If I click the node of the actor, then I can go explore the time series and its graph neighborhood of that particular actor when it loads. So yes, so you can see who drives traffic to the page of item driver. So our next work that I'm going to show is
so Lexing, just reminding you, you have 1 minute left.
Yeah, sure. So I'm going to skip through this particular demo on captioning images with knowledges. The demo is online. The last demo I was going to show was what we call influence flower. It basically is a way of wrangling the entire academic graph and showing people's incoming influences and outgoing influences through different fields and people and institutions. It's coming to archive as a plugin. So stay tuned. It's done by a great female student in my group. So to summarize, I've talked to you about different machine learning approaches in the full stack data machine learning, from data all the way to demos. My current interest is in understanding attention economy. I would love to have collaborators who are experts in the mathematical models in the microeconomic and macroeconomics. I also work on computational social science, biomedical imaging, and so on. I love to talk about statistical machine learning and enable other researchers to use machine learning. I won't be able to stay for the discussion at the end of today, but I just wanted to flag that it's great to hear Daniela's talk about YouTube and outreach, and great to hear about Kinan's talk about learning latent representations. There's a fair amount of new tools for doing this in the neural network land. That's all.